Imagine testing dozens of devices at once, without doubling your workload or duplicating code. That's the power of multi-threading DUT in PTEM. Instead of building separate test logic for each device under test, you design one set of test steps. PTEM takes care of the rest, creating virtual instances for every DUT you add to your test plan. This makes developing test plans both faster and simpler, while dramatically increasing your overall test throughput. But what happens when multiple devices all need to use the same instrument? Without careful coordination, conflicts can arise, risking both safety and test integrity. PTEM automatically manages requests from multiple DUTs using a built-in queuing mechanism. This demo demonstrates how simple it is to build a multi-DUT test plan while eliminating the need to manually coordinate access to the same instrument. I have created a simple test plan configured with 3 DUTs sharing a single DMM. The test plan contains one frequency measurement test step, which is executed for each DUT. Because only one DMM is available, the frequency measurement for each DUT must be executed sequentially to avoid instrument access conflicts. PTEM manages this automatically. There is no need to explicitly insert instrument locking steps into the test plan or manually serialize the test sequence. When the test plan is executed, PTEM automatically coordinates instrument access across all DUTs, internally queuing the requests and executing them one at a time. As shown here, the measurement results are returned and logged sequentially for each DUT. In some scenarios, it may be necessary to adjust test parameters to accommodate DUT-specific variations. This can be done directly in the test plan editor by selecting the target DUT from the drop-down list and modifying the required parameters. For example, let's adjust the limit tolerance for one specific DUT. After entering the new parameter value in the test step, PTEM automatically detects that the value differs from the global setting and immediately classifies it as a DUT-specific parameter. A DUT-specific parameter applies only to the selected DUT's test plan. All other DUTs continue to use the original parameter values without any changes. A DUT label is applied to the parameter to indicate that it is no longer shared globally across all DUTs. Let's run the test again and review the limits applied to each DUT. You can see that the selected DUT now uses the updated limits, while the remaining DUTs continue to operate with the original limits. Finally, if the updated parameter value needs to be applied globally, simply right-click the parameter and select Apply to all DUTs. The DUT label is removed and the new value is now globally applied to all DUTs. When the test plan is executed again, all DUTs now use the same updated limits. This concludes the demo, highlighting how PTEM streamlines multi-DUT testing with intelligent instrument management and flexible DUT parameter control. Don't forget to check out the other demos on Keysight Hands-on YouTube channel. Thank you for watching.